Good morning, everyone. My name is Donna.
And I'm Mina. Nice to meet you.
We're undergraduate research assistants from University of Buffalo. Over the summer, Mina and I participated in a undergrad research project that focused on corrosion effects on reinforced concrete structures exposed to coastal flooding. Here we have a photo of seismic events within the U.S. The goal of the project is to combine the damage caused by seismic events and rebar corrosion caused by flooding to determine the effects it causes on structures. Since areas that usually experience both seismic events and flooding tend to be in the coastal regions, that will be our focus for the project. Our presentation is only a small part of the entire project since it's a multi-year-long project with a larger scope. Our parts involved testbed inventory analysis and sectional analysis. The testbed inventory analysis focused on collecting and analyzing building inventory data for the testbed site, which in this case was the town of Hilo in the island of Hawaii. The town of Hilo is located on the shoreline, making it more susceptible to seismic events and coastal flooding. It's important to note that Hilo is an example community that was used for the purpose of the project. The collected inventory focused on a mix of buildings of different construction types rather than just concrete, but for the purpose of this presentation, we will look at concrete buildings. Some of the data that was collected included occupancy type, construction type, number of stories, year built, and building footprints for the purpose of mapping everything on ArcGIS Pro. The sources that were used included NSI, National Structure Inventory, Microsoft Building Footprint, and the Hawaii Planning Department websites. There was a verification process used to ensure that the data is all accurate. So Zillow was used, ESA Structures from S3 was used, and Google Earth satellite images were used. The extent of our coastal region within Hilo was determined by the USGS 100-year flood projections. Within that highlighted area, there are a total of 1,283 buildings. Out of those 1,283 buildings, there are only 76 concrete buildings. Other construction types that we looked at included steel masonry, wood, and manufactured homes. We also looked at occupancy types, which included commercial, industrial, public, residential, and hospitality. These were categorized by NSCI, and majority of the concrete buildings were commercial or residential. The rise of the buildings were determined by the number of stories as per the HAZES earthquake model technical manual. Majority of the buildings were categorized as low-rise, and for the ones that were not categorized, they would require further research.
All right. Hi, everybody. My name is Mina again. And my part was doing sectional analysis with the objective to understand changes in column capacity to the rebar section loss. Software that was used was SAP 2000, and for the next couple of slides, you'll see the material properties that were used for concrete. Here you see the unconfined concrete stress strain diagram, and here the steel. And parameters that were considered were, as you see on the left, the baseline section was a cross-section with number 8 rebars, longitudinal. Number 3 stirrups placed at 14 inches with a 2 inches clear cover. And on the right, you see the alternate sections considered. So we played around with the number of rebars, the layers of the rebars, the shape of the cross-section, the clear cover itself, and the cross-section area. Other parameters that were considered was the actual load. We investigated 0, 10, and 30% applied actual load on it. Exposure to corrosion, whether it was the entire thing. For example, baseline, we consider, for the baseline analysis, we considered all rebars being corroded, and you'll see moving forward, we had either mostly tension rebars or compression rebars, and the rebar area that was left after corrosion was either 100%, so indicates no corrosion at all, and 80% which indicates 20% rebar loss due to corrosion. That's how we correlated the corrosion itself. Here you see the baseline analysis. So fully corroded longitudinal rebars for 20% corrosion showed a strength drop of about 19%. Moving forward, we use the baseline results and we consider them throughout the rest of the effects. So for effects of axial load, we see from left to right for 0%, 10%, and 30% axial force applied on the column. We have respectively about 19%, 13.5%, and about 10% strength drop, which indicates that at low axial loads, we have a prominent strength drop. For the next effect, we see the exposure side. So you see again from left to right, the baseline is about 19%, where all rebars are fully corroded, while in the middle graph, we have mostly compression rebars being corroded, about 5%, and on the right graph, we have mostly tension rebars corroded, again at 19%. So the takeout from this slide is essentially either we have fully all the rebars being corroded or mostly the tension rebars being corroded. The strength drop is really prominent. Next one we were looking at is the effects of longitudinal rebar area. And as you see, whether we have 8 rebars or 4 bars, there's no really change in the strength drop. It's about the same. So this indicates that the longitudinal rebar area is insensitive to corrosion. Similar to the previous slide, all the rest of the parameters indicate, as you see from the table on the right, where the strength drop is about the same, between 17 and 19%. There's not really any sensitivity at all to strength drop. So essentially, strength drop due to corrosion is insensitive for longitudinal rebar parameters, because so far those slides were about longitudinal rebar parameters. When it comes to transverse rebar corrosion, we saw no strength drop. So essentially what happens here is that capacity has not been affected if the transverse rebar has been corroded 20%, because we're only looking to either not being corroded or being corroded 20%. And our conclusions?
Our testbed inventory analysis concluded with 76 concrete buildings, with majority of them being commercial, residential, and low-rise. Moving forward, our research will focus on spatial locations of these concrete buildings and the associated level of flood hazard.
And regarding the sectional analysis, as you saw from the slides, pronounced strength drop was only the cases where we had low axial loads or mostly tension rebars being corroded, while the rest of the longitudinal parameters had indicate no sensitivity at all. And of course, the corrosion of transverse rebars reinforcement had not really any impact on the strength capacity. And we'd like to acknowledge the National Science Foundation because that was the sponsor for our research project. And this is a QR code. Feel free to scan it so you can get more information for our website.